What's good, everybody? Welcome to a video on the Anabolic Matrix. Now, this is a term that was originally coined by Dr. Tony Huge, who you can see on the picture on the right there. And it's just basically a synopsis of all of the various compounds that bodybuilders use to be as anabolic as possible and build muscle. So, my categories are a little different than Dr. Tony Huge's original Anabolic Matrix. But you can see them here on the top of each of the tables. I don't actually use these drugs, but as a former biochemistry undergrad, I find it incredibly interesting. Getting into each of the categories here, we can see the first one is hypertrophy. Now, hypertrophy is just an increase in the size of a muscle cell. This is accomplished through increased muscle protein synthesis, which just means increase in the translation of actin and myosin to create more myofibrils within each muscle fiber. And steroids, anabolic steroids specifically, not anti-inflammatory steroids or things of that nature, are the most prevalent hypertrophy compounds. These steroids are all derived from the original testosterone molecule, and then they've just had various slight modifications in order to acquire maybe more specialist properties, such as increased anabolic activity, decreased androgenic activity, meaning like male characteristic driven effects, increase the aromatization of testosterone into estrogen, or become bioavailable orally. And they basically act by binding to the androgen receptor to stimulate protein synthesis. And then SARMs as well do a very similar thing. However, these set of molecules are actually patterned after anti-androgens in your body. And they're called SARMs, selective androgen receptor modulators, in the hopes that they would be more selective to only muscle tissue and not give any of the masculinizing effects that some steroids do. So that women and children could take them. The second category is hyperplasia. Hyperplasia is the creation of new muscle cells either through the splitting of current cells or the transformation of another cell, such as satellite cell or stem cell, into a muscle cell. This can be accomplished primarily through IGF-1. Now, you can either take IGF-1 directly, which is kind of an unstable molecule and hard to acquire, or you can take human growth hormone, which will stimulate the synthesis of IGF-1 in various tissues. So if you take it at a high enough amount of growth hormone, it will be translated into IGF-1 downstream and then have that hyperplasia effects. And then it's also been shown in some capacities that, if you're able to introduce satellite cells or stem cells, while also having some of these other growth factors there, they could potentially become muscle cells. But the difficulty is if you introduce these pluripotent cells that can become any kind of cells, then potentially they can become bone cells or organ cells or other cells that you don't necessarily want, as opposed to just being muscle cells. And then extreme stretching, which really hasn't been shown in humans a lot. There's just some kind of like bird studies where they'll hang hundreds of pounds off of birds' wings and it will kind of force them to create new muscle cells to compensate, but not really applicable to people, just kind of a cool example. The next category we have is increased nutrient delivery to your muscles, which obviously if you have increased nutrient delivery, then your muscles are able to, grow better. It's like having better fertilizer. Insulin, which is just key that allows more nutrients to flow from being in your blood into your muscle tissue, so you can actually store more glycogen and get more amino acids to use as building blocks in muscle. We also have EPO, which it's also called erythropoietin. This increases the amount of red blood cells you have, which increases the amount of oxygen that you can hold in your body. And if you have increased amount of oxygen, you can use that oxygen to create energy to recover your muscles. And not only that, if you have more oxygen, you can train harder and also recover from it in the same capacity. So it reinforces the ability to grow muscle in a variety of ways. And then the Viagra and Cialis kind of fall into very similar categories where phosphodiesterase breaks down cyclic GMP, which stimulates the release of nitric oxide. So by taking these inhibitors, you have much higher nitric oxide, and this is the chemical that opens up your blood vessels. If you take these, and you'll have much better blood flow throughout your body, and if there's more blood able to circulate and get to tissues, and ultimately it can be nourished by the nutrients the blood carries. The next category you have is increased androgen receptor density, which can be achieved via either steroids or something called L-carnitine. And why you want this essentially is the androgen receptor is the receptor that steroids and SARMs use to elicit their effects. So if you have an even greater amount of androgen receptors to receive steroids or SARMs, you can take higher doses and still get more and more beneficial effects. I put muscle catabolism and specifically trenbolone. So all steroids have a certain level to which they inhibit muscle catabolism. But I specifically wanted to mention trenbolone because it's actually been shown to directly bind to the glucocorticoid receptor and block cortisol from binding. So cortisol is your stress hormone. So normally you release cortisol into your bloodstream. It will bind to glucocorticoid receptor in order to get as much glucose into your blood as possible because it thinks you're in a fight or flight situation and you need as much energy as possible. And so this cortisol will draw from anywhere to get that glucose into the blood, whether that's already existing glycogen stores, already existing glucose, fat, and it will definitely chop into your muscle. So by inhibiting cortisol attachment and effects from the glucocorticoid receptor, you will actually retain more muscle. Moving on to myostatin inhibitors. Myostatin is a mechanism that basically prevents humans from gaining too much muscle because ultimately muscle is very metabolically taxing and demanding in terms of like oxygen consumption and nutrients, so it's not really in our best interest to have a lot of muscle. By inhibiting myostatin, you're essentially eliminating that cap to your body that your body sets as to how much muscle that you can build. And as of right now, we don't officially have good myostatin inhibitors. The only one that is currently being researched and people have been using and testing is YK11. Moving on, we have inflammation. So this is kind of an odd one. You do need a certain low level of inflammation that's caused from training or arachidonic acid, but too much inflammation can actually be detrimental. It's kind of a fine line as to how much inflammation you want. However, arachidonic acid listed here is basically an omega-6 fatty acid, which helps to create prostaglandins and prostacyclins. So those are hormonal molecules, and they cause inflammation in the body. And so arachidonic acid has been shown in studies to create more muscle over time. They don't necessarily think it's because of increased inflammation, though. So take that kind of with a grain of salt. It could have some other hormonal effect that they haven't quite elucidated at this time. And then last, I just put caloric surplus because the bottom line is in order to facilitate the growth of muscle or any kind of anabolic process, you need a surplus of energy.